All right, we're going to play around with factored forms of polynomials. Getting the factors is a hard problem. You have to solve the problem polynomial equals 0. It's not trivial. I'll deal with with some of the ideas for dealing with that and figuring some of that stuff out. Although doing it in full is a bit beyond what we need to do or can do. But first, before you get into the realm of factoring, you have to understand just what it is that these things are telling you. So let's start simple. So x plus 2 times x minus 3. So this thing tells me the following information. At minus 2, I have a 0. Why? Because when I put in x equals minus 2 in there, I get, so at x equals minus 2, I have 0 times x minus 3, which is 0, right? Because x plus 2, when x equals minus 2, is 0. And then you also have at x equals 3, you've got x plus 2 times 3 minus 3, which is 0, right? That's 0. So the whole thing is 0. 0 times anything is 0. This is what we got. Now, what else do we know? Well, we know that x equals 0 leads to 2 times minus 3 equals minus 6. Just plug in 0 in for x, you get those constant numbers, right? So that's minus 6. So that's somewhere down here. What else do we know? Well, think about this. Let's say x is about 1 million, right? If I add 2 to it, what do I have? I have a million. What happens if I subtract 3 from it? I have a million, right? If you have $1 million and someone wants $3 and you give them $3, how much do you have? You have $1 million. You can't do that forever, of course, but it would take a very long time before subtracting 3 from 1 million would get you anywhere. That means that this thing, x plus 2 times x minus 3, is approximately 1 million squared. Very large. So it's way up here. And similarly, if x is, say, minus 1 million, then that's also minus 1 million squared, which is just positive. I mean, when you square 1 million, you get a trillion. Positive a trillion. 6 zeros. Square it, then you have 12 zeros. And 12 zeros is a trillion. Okay. Anyway, so we also have this, right? And so now we know kind of what it looks like. Boom, boom. And in general, you don't know where this vertex is. Here, there's only 2 factors, so this is actually a quadratic. So it's halfway between, which is, so it's somewhere like this. Oops. I totally missed the... So something like this, and you got to go through the actual zeros. There we go. So that looks like something like this. Now, what happens if I just add another factor? So x plus 2, x minus 3, x plus 1. Well, now I've got minus 2, minus 1. Still have my 3 over here. Now it's looking like So it's kind of like x cubed for large x, right? So there's just, and so that's going to be like this, and that's going to be like this. All right, and so now I can just connect the dots. It goes up through a 0, comes down through a 0, goes up like this. All right, so let's take a look at GeoGebra. First there was the problem before, x minus, x plus 2. So just one factor is a line. And then we get our quadratic. That looks pretty good. Vertex halfway in between, goes through minus 6 here, goes off to infinity. And then I have my cubic. See? Comes up from minus infinity, goes through the 0, hits a maximum, comes on down. Also, this thing's going to be minus 6 because 1 times minus 6 is minus 6, so that's fine. Hits a minimum down here, goes up through 3, and there you go. No longer are things halfway in between in general. So let's look at the extremum here. So it's you get minus 1.53 over here, which is not the halfway point between minus 1 and minus 2. It's near it, but it's not. So cubics are mutating these kinds of things. We've also got one down here, 1.53. I don't really know why that's at the same point, but whatever. That's that. And now you can just kind of keep on going like that, right? So let's say that I had x plus 2, x minus 3, x plus 1, and let's say x minus 1. Now, I can put any numbers I want here. Just trying to keep them nice and simple. Minus 2, minus 1, 1, and 3, right? So now this is kind of like x to the 4th. Okay, so x to the 4th is going to be positive up here and positive here. And now at x equals 0, we're going to have plus 6 if you multiply all that out. So we also have something like plus 6 up here. Okay, let's see how that works. So you go down, up through here, comes back down, goes up like this. Basic setup. So, x minus 1. There you go. All right, so not symmetrical. Also not halfway between various roots or anything. Oh, there's actually a maximum near the origin. There, get your roots. The roots are just where the factors are 0, of course. Oops. There we go. Okay. Now, if I were to have a negative in front of all this, it would be flipped, right? So if it was negative x plus 2, x minus 3, x plus 1, x minus 1, and now that would be minus x to the 4th, and it would go like this, come down, like that, right? It just flips around. All right, and as you add on more factors, these things happen. What else can we do? You could have the same factor. So now let's reduce the size of what we're doing here to x plus 2 squared times x minus 3. So we still have minus 2 and 3 as our roots, but we only have 2 roots instead of 3, even though we have 3 x's. And we have, it's x cubed, so it's like this and this. Massive x, can just multiply it out. If for large x, you can ignore the plus 2 and minus 3, so it's just x cubed. So if you have a big negative number, you have 3 of them, so you get a negative number. If you have 3 positive numbers, multiply them together, you get a big positive number. All right, so if I were to do this, that would be bad, right? Because I need to get up here. So I have to bounce somewhere. And where do I bounce? Well, x plus 2 squared means it doesn't change sign because it's squared. This is always a positive thing. So basically what happens is that it looks like it's a quadratic here at this 0. So then it comes back down and voila. This thing will be like minus 12 or something. All right, and we can see that in GeoGebra. Just delete all that, and there we go. So you can see how it bounces here. So you have your maximum at a root. Goes like that. And if we were to increase it to a cubic power, then it looks like a cubic at that point. X to the 4th, massive. So we still have minus 2 and 3. Starts up here, ends up here. Basically, you would come in like this, kind of graph it like it was a cubic. Going through there, it goes, this is probably like minus 24, and then it comes up like that. All right. So there we go. Let's see what zoom to fit does for me. Oh, not good. Standard view. Oops. And there's our minimum, which is getting quite large. As you add on extra factors, these things get larger and larger. So that's a little bit of factoring, and it's once you have the factors, it's kind of easy to sketch it out. Oh, I guess what happens if we add in say, so we've got x plus 2, x minus 3, and let's say that we add in a polynomial with that has no zeros, no real zeros, so, or multiply in, I suppose. So let's take a quadratic, plus 4x. So x squared plus 4x at minus 4. it'll have its 0, so minus 2 is the vertex, minus 2 squared, 4 minus 8 minus 4, so minus 4. So if you add in 8, this should have no zeros. All right? Okay, so assuming I did that right, then we have minus 2, and we've got 3. This is kind of like x to the 4th, mass of x. So it's like this and like this. At 0, it's going to be minus 48. All right, and so we cross here like this, come down here and go up like this, and, you know, is there something else going on? Maybe so. So, yeah, maybe some other max min. You know, we've added 2 factors, kind of 2 linear factors, 1 quadratic factor. So maybe there was something weird that happened with that. There's only one way to know. Let's see. So this was, just do that now. Why is it yelling at me? Okay, now it's happy. Gotta keep the machines happy. Plus 4x plus 8. Alrighty, so you can see it's pretty narrow, like so. A little bit of strangeness going on, but there wasn't any really extra max or min going on. It's getting very narrow. Well, maybe a standard view might help. There we go. But yeah, pretty steep. Doesn't look like it added any max or mins, so that's cool. It can get complicated, but yeah, focus on the zeros, see what happens. So that's kind of graphing with factors. So that's one of the reasons factors are so nice. I mean, one, we care about zeros, but one of the reasons we care about zeros is just kind of knowing the signs. And it's really easy. You look at mass of x, which is nice. You just drop everything except the x's. You see what it looks like. X to the 4th, x cubed, whether, you know, and there might be some negatives. So maybe I should just point this out. So if you had like 2x minus 3 times, you know, 3x plus 7, it's not entirely a pleasant thing, but x over, so 3 halves, oops, 3 halves would be a 0, and 3x plus 7 would be 7 over, let me just change this. I just want to make a point here. Yeah, I got a point. Yeah, 3 halves, and then minus 7/3, which is like minus 2 1/3. And now, what is this thing for mass of x? So again, think a million. I mean, 10 works, right? 10's big in these things. 100 works. It gets big real quick. But just for sake of like absolutely wiping this thing out, think a million. X equals a million. You know, what do we got? We got minus 2x times 3x, or about minus 6x squared. So it's going to be an upside down parabola, like so, and like that, right? And so that's just how I think. And you know, if you had a square, then minus 2x. Oops. If you had minus 2x plus 3 squared, 3x plus 7, you know, it's going to be the same kind of thing. And it's just the zeros. And we've got a little bounce factor here. This is going to be now minus 2x squared 3x for massive x. So that's just 12x cubed. All right, so you square, you get x squared, multiply by x, you get x cubed, 12x cubed. So it's going to be like this, and then like this. It's going to go through here and then bounce, go up like here. Bounces here because of that square. Looks like a parabola there. All right, doesn't change sign, bounces. It's good stuff. All right, and again, you can graph this stuff. You know, to get good at this, I would suggest just writing down a bunch of factors like this, trying to graph it by hand. You know, think massive x, think about what the zeros, what the behavior is at those zeros. You know, does it bounce or not? If it's linear, it doesn't bounce. Or if it's an odd power, it doesn't bounce. It'll, like a cube, it'll flatten. Well, as the powers get higher, the thing flattens out more and more there. And then just connect the dots. Draw it out. Now you might miss some wiggly stuff in the air somewhere, the max and mins. But pretty much you get a good starting point, and then you can gain intuition with something like GeoGebra.